All right. One more graph. Well, there's a couple more graphs, but one more graph just related to this. I zoomed in even more. So the last graph was looking at these measurements at Mauna Loa for the past 60 years, pretty much ever since they started recording it. This graph zooms in. We're only looking at 5 years. And the reason I want to zoom in, and you may have noticed it on the previous slide, is that this red line trends. It increases and decreases, increases and decreases. The black line is just the average, so don't worry about the black line. You notice with this red line that despite it increasing and decreasing, increasing and decreasing, it's still increasing, right? The general trend is still increasing. What I want to talk about is why. Why do we see this? It happens every year. It's always happened every year. So let's talk about it. Let's talk about why it's happening. So let's focus on 2019 to 2020, so a single year. So here's 2019, that was really poor. Here is 2020. So what you might want to do in your notes is kind of draw what's in between these two green lines. Ignoring the black line, just draw the red line. We see that the red line is, I guess, in the middle. And then it increases, and it's at its peak, that's probably about April. And then it starts decreasing, it starts decreasing, it starts decreasing, and it's at its lowest in about September. And then it starts increasing and increasing again. So this is what I want to focus on, is what's happening in a single year. It's increasing reliably and peaking in April, and every year it's decreasing reliably and reaches its bottom point in September. But why? What's happening? And it has to do with seasons. It's actually a seasonal thing, and the biggest thing that's happening in the seasons is plants. Particularly trees, but really plants as a whole. So remember, plants do photosynthesis. So photosynthesis, and let's recap photosynthesis real quick. We have carbon dioxide plus water plus sun. It's going to give us sugar and oxygen. So when photosynthesis is happening, right, when the trees have their leaves, they're soaking in all of that carbon dioxide. And so when photosynthesis is active, aka when plants have trees, when plants have leaves, when plants are alive, carbon dioxide goes down. So in April, this is when plants start re-emerging. This is when trees start growing their leaves back, and they're photosynthesizing. And as they're photosynthesizing, carbon dioxide's decreasing. It's going down and down and down until about September. Well, what's happening in the fall? Well, the leaves are dying and falling off the trees. Plants are dying. And so there's nothing photosynthesizing anymore. So then what we see is, well, there's no photosynthesis, which means carbon dioxide isn't getting taken out of the atmosphere. So it's just increasing and increasing and increasing until we come back to the following April. The leaves are coming out, they're soaking in carbon dioxide, etc. So we see this every year, and I like to focus on it because the cure to climate change is not planting more trees. It's one of the biggest things that just bothers me, because every year that carbon dioxide goes right back into the atmosphere because the trees are dropping their leaves, they're decomposing, and that carbon dioxide gets re-released into the atmosphere. It makes a very small difference year to year, and it just gets reversed anyway when the leaves come back, and when the leaves fall off, and when the leaves come back, and when the leaves fall off. I'm not saying we shouldn't plant trees. Do not take that away from this. I'm just saying that's not the solution. The solution is not planting more trees. The solution is lowering emissions. But just want to put that out there. One last thing. If it is spring and summer here, it's April, it's warm, those trees are starting to leaf out, your plants are starting to emerge again. What's happening in South America? Right? Their seasons are opposite. Their April's dead of winter, or well, maybe not dead of winter, but it's the starting of their fall. So in the southern hemisphere, This should be flipped, right? Sure, we're starting to photosynthesize more, but their leaves are starting to die more. Why is this just not a straight line? Don't they even each other out? And while that is a great thought, they don't. And the reason they don't is if we see Earth, here's Europe, here's Africa, here's Canada and North America, there's Florida. Central America, South America, okay. And the equator runs about through there. Most of the vegetation on Earth is in the northern hemisphere. So I'm gonna draw, see, we got all these trees. So most of the vegetation is found in the northern hemisphere. Meaning when it's the northern hemisphere spring, when it's our springtime in April, this is why we're starting to see this decrease. What's happening in South America, what's happening in Southern Africa, although they have vegetation, it's not a lot. And so it's not evening out this trend because we just have so much more plants than they do. And so this trend that you're seeing is being dictated by the northern hemisphere's spring. That's why we're seeing this huge decrease in carbon dioxide, because it's springtime in the northern hemisphere. Sure, it's fall in the southern hemisphere, but they don't have a lot of trees, so it doesn't really matter. Okay, I know, lots of grass, but again, it's so important to kind of understand what's happening. Because, as I mentioned before, we can easily say, hey, planting more trees won't solve the problem. Here's the data that backs that up. So this data is incredibly important. I encourage you, if you want to print out these graphs and kind of label them and kind of describe why these different pieces of information are important. So everything that we saw was looking at global carbon dioxide and global greenhouse gases. But we don't have global laws, right? We don't have things that are controlling every body, governing body the same. And so it's important when it comes to actual policies, when it comes to actually making a change, to look at what's happening around the world on a country by country level. Because at the country level, we can make laws. At the country level, we can dictate what kind of technologies are being invested in. So this first question, which country leads in total greenhouse gas emissions? So looking at that entire country, how much gas is coming up? Now I'm just going to look at 1970 first, and we'll talk about present day. In 1970, the United States is this yellow line. We are the top line. Ignore the black dashes. This is just saying everyone else put together. And if we look, yellow's leader, still leading. 1970, here's 1980, still leading. 1990, still leading. 2000, still leading. And then something happens. So from when we were measuring it in 1970 to 2004, the United States was leading the way in greenhouse gas emissions. I'm going to keep talking about the US for a hot second. But you notice we started declining. Not a lot. But we have declined. We actually do have policies in place, that's going to come in a future lecture, that have declined our greenhouse gas emissions. But what you may notice is in 2004, we got overtaken by another country. We got overtaken by China. Now this is kind of impressive because prior to 2004, China had a whole bunch more people than us. They still have a whole bunch more people than us. They have about 1 billion people more than us. Yet it wasn't until recently that their emissions surpassed ours. And that's because China has been undergoing industrialization of their 1.3 billion people population. When the United States underwent our industrial revolution, we had about 300,000 people, and we polluted a lot. Like, we are not angels by any means. But it was with 300,000 versus 1.3 billion people now industrializing. They have far more coal plants, far more resources being used than we did. And so while China is a major emitter, it's also like, hey guys, I know you're trying to develop, I know you want electricity, I know you want to have industries, but You can't. I know all of us did that process, but you guys can't. And this is where it's important to understand like country politics. Like we can't just say, "Oh, you guys can't do what the rest of the world has done because you have too many people." Okay, you guys need to stay in your rural farming communities. You can't better yourselves. So keep that in mind. Like don't poo-poo on other countries because they have to face very different economic things that we do or that we did. But it's good to know that the U.S. is not the worst anymore. We held that title for a long time, but now we're the second worst, despite having like the only third largest population with China and India much above us. All right, so this was looking at total greenhouse gas emissions. I do want to just point out the link that's at the bottom of this page goes to a website that shows you in a map form emissions since I think it might be the 1800s, it might be the 1900s, the early 1900s, I can't remember. But if you're interested in history, if you look during certain wars and where those wars took place, you can see how their carbon dioxide emissions changed, which is pretty cool. And it shows the countries in relation to each other. Just spend 5 minutes on that site. It's a really interesting site. I love playing around on it.